This is CPM Precalculus, Chapter 3, number 23. Each of these graphs is reflected over one of the axes. Find the equation of the resulting graph. So A, we have the function f of x is equal to 3x squared minus x. And we're going to reflect it over the x-axis. Okay? So remember, our y-axis, our x-axis. This is our x-axis. So we're going to put whatever graph we have here, and we want to reflect it across, making this our mirror. Right? Our x-axis is our mirror, and it's going to reflect something like this. Right? Anyway, we also know that if we have a function f of x, the transformation of reflecting over the x-axis, right, is just going to go ahead and become negative f of x. Right? So if we start with f of x is equal to 3x squared minus x, right? I'm just going and setting what that is. Well, negative f of x is going to be negative of this whole thing. So put a negative in front and go ahead and say negative 3x squared minus x, right? So that gives us the new equation. Distribute that negative. It's going to be negative 3x squared plus x, all right? That's going to be the new equation. Another way of thinking about this, let's just do another way, is when we go ahead and reflect across the x-axis, we know that means every y value is multiplied by -1, right? The reflection of the x-axis, all we are doing is we're multiplying every y value by -1. Our initial equation was f of x is equal to 3x squared minus x. We could write that as y is equal to 3x squared minus x, right? F of x is just the name. Well, every y value is multiplied by -1. Let's just multiply every y value here. Well, we get only 1, so that's negative y is equal to 3x squared minus x. Then if we solve for y, we're going to multiply both sides by -1. These cancel out. We're left with y is equal to, distribute the -1, negative 3x squared minus 1. And this is the same, right? And this is one process where we understand that reflecting over the x-axis means putting a negative in front of f of x, right? We also understand that that means every y value is multiplied by -1, and both those ways will solve the problem. Part B, we have the same function, f of x is 3x squared minus x, but now we want to reflect over the y-axis. Again, this one's our y-axis here, right? And so if we have something like this, let's make it like this. Our reflection is going to make this the mirror, right? The y-axis the mirror, and it's going to be something like this, right? I didn't do it so well, but you get my point. We're putting a mirror in the middle, and that's the reflection. So we know if we start with f of x, to reflect across the y-axis, we want to go ahead and put inside the parentheses that x is going to be negative, right? So if we start with 3x squared minus x, and we plug in negative x, right, we're going to have 3 times negative x squared minus negative x. I'm just changing every x to be negative x. Well, I can simplify this. Negative x squared is just 3 times negative x times negative x minus, well, this I can see becomes a positive, so plus x. 2 negatives cancel out, so that's just 3x squared plus x, right? These is just x squared. So here is the result for reflecting over the y-axis. Thinking about this like we did here graphically, we know every x value, right? We're multiplying every x value is multiplied by -1, right? So if we start with y is equal to 3x squared minus x, we want to go ahead and multiply every x value by -1. We get y is equal to 3x -1 times x squared minus -1 times x, right? Well, simplifying that, -1 times x squared is again just negative x times negative x, or positive 3x squared, because the negatives cancel out. Here again, they cancel out, and we get 3x squared plus x. And you'll notice either way of thinking about this is going to result in equivalent equations for the reflections. Okay? So that's going to end for our CPM Precalculus Chapter 3, number 23.